Welcome to the discussion and thank you for always joining us. We are looking at K.c.s.e 1997 paper 2 question number 23, a question on bearing. And the question we have reads: two aeroplanes S and T leave airport A at the same time. S flies on a bearing of 60 degrees at 750 kilometers per hour, while T flies on a bearing of 210 at 900 kilometers per hour. Using a suitable scale, draw a diagram to show the positions of the planes after 2 hours. Then use the diagram to determine the actual distance between the two aeroplanes, the bearing of T from S and the bearing of S from T. So we are going to begin by calculating the distances because we have the time and the speed. We have aeroplane S leaving airport A and also T leaving airport A. So we have A T, which is having a speed of 900 kilometers per hour. You multiply by time. Remember, distance is given by speed times time, and this one is going to give us 1800 kilometers. We also have S leaving A, so we are going to have AS moving at 750. For 2 hours, it is going to cover a distance of 1500 kilometers. So I prefer to use a scale of 1 centimeter to represent 200 kilometers. That means AT will be 1800 divided by 200, giving us 9 centimeters. And now AS will be a total of 1500 kilometers. You divide it by the scale, and this gives us 7.5 centimeters. So we are going to begin with airport A. At this point, we begin with the airport A. So this is A. Remember, T is leaving. We begin with S. S flies on a bearing of 60 degrees. So from A, we are going to measure 60 degrees. Remember, angles are measured from the North Pole in the clockwise direction. So we are going to measure 60 degrees. 60 is at this point. And then from there, we are going to draw a straight line joining port A. Remember, AT is 9 centimeters, but AS is 7.5, so this is 60 degrees. So we measure 7.5 centimeters. .5 is here. So at this point, we are required to draw another compass. This is aeroplane S. Then we have also been told that T flies on a bearing of 210. So we are going to move all the way from the North Pole of A up to this point here. We have 180. So we are going to add 30, so that if you take 180, you add 30, you get 210. So this is what we have. Up to this point we have 180. So we are going to add 30. 30 is at this point here. This is where we have 30. So we are going to draw a straight line from airport A all the way towards T, and the total distance from airport A to T will be 9 centimeters. So this is 9 centimeters, and AS is 7.5 centimeters. So we measure the distance here. Nine centimeters is around this point here. So at this point again we come and draw another compass. So this is where we have our T. Once we have done that, we can now join the 2 points. We join T and S. That is a sketch diagram or a scale drawing showing the positions of port A, aeroplane T and S. Then from there we are supposed to work on the questions given. 1. We are supposed to determine the actual distance between the 2 planes, so we need the distance TS, and in this case we are going to measure the distance between the 2 in centimeters, then convert them back to the scale. So if you look at the distance here, we have around 16.1. The distance is 16.1 centimeters. We take 16.1, we multiply back. We are using the scale. Remember the scale we used is 1 centimeter to 200 kilometers, so we multiply by 200, and this gives us a distance of 3220 kilometers. Having done that, we are through with part B, because A was about drawing. Roman 2 of part B, we are supposed to find the bearing of T from S. So the bearing of T from S. So you go to S. Remember, we measure angles in the clockwise direction from the North Pole. So we are going to move from the North Pole of S and move all the way to where we have a line going to T. And in this case, we are going to move from the North Pole to this point, which is 180. Then measure the angle in between here. The angle at this point here, which we can call angle theta, can be determined. So using the protractor, we already have 180 degrees. We add the angle theta there. So we can determine the angle theta by using our protractor here. And according to our angle, this is around 44 degrees. So it's 180 plus 44, giving a total of 100. That is 224 degrees as the bearing of T from S. Next, we determine the bearing of, next we determine the bearing of S from T. The bearing of S from T, that is Roman 3. Bearing of S from T. So you go to T and measure the total angle from the north pole of T to where we meet the line moving to S, and measure the angle here. Using a protractor, we are going to determine the angle, and in this case you realize the angle is approximately 45 degrees. Of course, we might have a plus or minus 1 so that we allow an error of 1 degree. That becomes the solution to that particular question. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.